Uh-oh, now we lost your video. There you are. Why don't you give us a little overview on what's going on while I load the presentation for the company?
Very good. I have the entrepreneur next to me. And we have also the presentation online, so you can use the link also.
I have it on my computer. Do you want to do it online?
Yes, it depends on him, how is better for him to present the elevator pitch.
Fine. Why don't you go ahead and do it?
Okay, just to say good morning to everybody.
Good.
And I heard you saying that I got married on the 10th, 10-10.
That's right.
Okay. So just to certify on that.
That's right. And from a mathematician, I would expect nothing less.
Okay. So I would like to introduce a young entrepreneur from Greece, Vasilis Nikolopoulos.
Say that three times fast.
He will have the opportunity to give you a small presentation of his business plan.
Excellent.
Okay? Enjoy.
Thank you.
Okay. Good morning.
Good morning to you.
From Athens, thank you very much for your time. My name is Vasilis. I just skipped the surname. It's a traditional huge Greek name, so it's better for you to be known as Vasilis. I will have in front of me the presentation. We have uploaded to SlideShare, so I will have it in front of me so as to be.
They can load it also.
Is it? Okay. Is this the Windows 6? No. I just want to have it in front of me. Okay, let me send you the link from the presentation.
Let's see if we can open the link on this part.
Exactly. Just a moment to write it down. Okay. Okay, this is actually the link to the presentation, so you can, instead of looking at me, you can look at the presentation. Okay, just will be better for you to be synchronized.
We're trying to open the link now.
Okay, just waiting.
No? We didn't see the link come through. I have your presentation on my laptop.
Yes, it was initially what Ioannis has sent you. So you can open the same presentation as well. It is the same.
I think we're going to do it that way since I can't open both presentations at one time. I can't have you and the link going at the same time.
Okay. So I can start. I can start talking. Okay, and then you can circulate the presentation to the to anyone who is interested.
That's fine.
Okay. Okay, just to start a bit, what we have and what we are. Okay, we are a bunch of young PhDs. The whole idea started in roughly in 2006 when I was a PhD, second-year PhD student at the National Technical University of Athens. Roughly my academic background has to do with a 4-year honours in engineering at the University of Dundee in Scotland. I then received some scholarships at MIT as well with Professor Bertsekas, but I prefer to stay in Europe. I then pursued a Master's of Science in Control Systems from Imperial College, a 3-month intensive course at LSE, London School of Economics, regarding entrepreneurship and management. Then I was for 2 years in France at the military school École Polytechnique, where I've done some advanced engineering courses in theoretical computer science and advanced mathematics. Then I returned to Greece. As you know, all Greeks, we have to do the military service. It's compulsory, so I had to return after roughly 7 years in Europe studying. And then in 2004, I started my PhD at the University of Athens, Technical University of Athens. My initial research was in energy information systems. So what I'll be talking today, it's about smart metering, it's about smart grid applications. It's a really hot topic in the United States right now. I started my research, and when I was in roughly my second year, my initial thought and initial plans was to use actually my research in order to create services. So we're talking about an advanced and applied research in order to create new services by following an entrepreneurial spirit. Something really difficult here in Greece because, as you might know, the entrepreneurial spirit, it's not well popular in the Greek universities. What we had tried to do was to create some specific algorithms, to create specific services in order to take meter data. So the first level is to create a smart grid, to enter into buildings and measure in real-time energy consumption. The second level is to create specific software as a middleware in order to take the data, store the data, analyze the data, and then the third layer is to provide services to the end users, the end consumers. We had some initial thoughts under research and under an R&D basis back in 2006, and then I decided to create an internal research and development team inside the university. So we could then be considered as a spin-off research and development group inside the university. Our research went on. I just used other 4 engineers who were in my team back then. And in 2009, we managed to set up here in Greece the so-called Intelen startup company. The Intelen comes from intelligent energy. It's an abbreviation. Intelen was initially the research and development group back in 2006, and now in 2009 I just founded the startup called Intelen. And as a business focus, it's the energy ICT, it's the energy information system. So we are creating software, we are creating services on the energy sector, services that are based on some specific principles such as cloud computing, such as smart metering, in order to offer our end user customers with services that I will explain later on. So initially we had great ideas. We had some initial cooperation with EDLU and the Google Power Meter team. Imagine that we were trying to do the same thing. Okay, we're trying to build software to analyze and to apply specific advanced data mining algorithms and procedures into meter data. We had worked together. We had created some gadgets, some Google gadgets. Now you can see that on the presentation that you have, or either online. Our site is intelen.com, so you can join and see what exactly we're doing. We have some videos as well. What have we done since 2007? In 2007, it was the first time that we took part in a national innovation competition league here in Athens. It was organized by OTANET. It was actually the national ISP. It's like the BT in London. Where we took the second place in between, I think, 2,500 ideas. The basic idea was a smart portal from which some customers could log in and see their energy profile in real time. Later on, we have applied to the Innovate 100 contest. Apparently, you might know it's organized by Guideware Group. It's a very known in the US. We were screened by their analysts, and we were shortlisted as one of the prominent top 100 best technological startups worldwide. This was last year. We had our pitch, our European pitch in Paris, and now we're just expecting our G-score results and our actually ranking inside the top 100 best technological startups. This is actually a brief history on our, let's say, innovation prizes. Recently, the Red Herring magazine, they just give us a place in the top 100 startups in Europe, most innovative startups. And recently, 1 week ago, we were proposed for the Global Award, the top 100 worldwide. Another two, let's say, prizes, we were proposed by the European Commission as one of the best practices in eco-innovation. And we were also candidates for the European Smart Metering and Smart Grid Award for the 2011 huge conference that will be held in London, UK. So this is roughly a brief history. And let's talk about our service now, and let's talk about our strong differential points. So as I explained you, our focus is create software based on the cloud computing philosophy. So we have something online, we have streaming algorithms online. Those algorithms, they accepting data from installed smart meters. It could be electricity, it could be gas, it could be water. So we are talking about a utility, the utility sector. We are just accepting those measurements in real time, and our middleware analyzes the data, ranks the customers according to specific key performance indicators and specific ranking algorithms that we have developed, and we are creating services. What are those services? Those services can be considered as smart grid application. The smart grid domain, it's a really hot topic now in the US. And this is why we have a huge interest in expanding to the US market. Of course, we have big competitors, good competitors. It's the eMeter. It's a very big company in the US that does apparently does something similar to us. It provides and produces MDM, meter data management software, and meter data management information systems. Another good competitor is the O-Power, a similar company that has us focus not to create smart meters, not actually to create integration between a smart meter and a software, but actually by using existing meters to create awareness, to raise awareness in the citizens by analyzing the data and presenting the data with the simplest way to the end customer. So one other hot topic is awareness, which is the first step for the energy services provision. What are our strong differentiation points? First differentiation point is that because we are from a very tiny country, and this was actually one of the initial questions that I had in all my pitch slams that I had so far from US analysts. The first question is focus. What are our focus? As you might know, if we were in the US, we would do something specific, something focused, and we would carry on that. Because we are in a very tiny company, in a very tiny country, and in a very tiny company, we're obliged to do many things in order to survive. So we are doing, we're analyzing, we're developing specific programs for smart metering. We are developing specific programs for meter data management. We are developing specific hardware for specific smart meters in order to actually do the integration between third-party companies that have smart meters, such as Itron, such as Lattice and Gear. So we are trying to develop algorithms and develop protocols to integrate our platform, our MDM platform, with third-party meters. At the same time, we are working a lot in the specific algorithmical part of the analysis. So as Google takes as a feedback based on the PageRank algorithm, it takes some inputs and provides rankings on sites according to keywords. We are taking as input metering data, such as energy. We are taking some third-party or external data, such as degree days, such as specific temperature and climate conditions on the end sites that we are measuring. So we are taking some other data and we are using some fusion algorithms in order to extract decision, in order to extract some decision support services on the analysis. What I mean? I mean that if we, for instance, we are measuring in real time 100 buildings in the New York area, and we have the characteristic curve of the building, which means energy consumption. We have internal temperatures, we have external temperatures. We can deduce, we can decide if the installation of those buildings are okay. Okay, so this is a simple example. We have specific algorithms that if we enter into a company, if we enter into a home consumer and we are able to measure and analyze the home appliances, which means the fridge, the kitchen, we can, according to some specific data fusion algorithm, we can decide if your fridge is of an older technology and has to be changed. This is a service. This is an intermediate service that we can offer by measuring and analyzing those data. So one strong differentiation point, it's, as I told you, we have very strong ranking algorithm. We are not staying only in the raising of the awareness. So this means information. We are analyzing the information in order to raise the level of complexity, which is of course transparent to the end user as Google ranks. I mean, in the back, many mathematical algorithms are passing by, but the result is that I have the best ranking according to my keywords. So imagine that if I can measure 50,000 energy consumers in the New York area or in other US area, I could run those customers according to some specific criteria. What are those criteria? Peaks. Which are the customers that have the highest peaks? Periodicity. Who are the customers that have a specific peak in a specific time every Wednesday? Why this information is important? Because if we have on the back a smart grid company, General Electric, if we have Pacific Gas, if we have a utility company, they could actually use those analytics and the output of this analysis in order to offer services. What kind of services? Demand side management, energy trading, adaptive pricing in terms of energy billing, the time of use, let's say, pricing. There are many services, energy services, that come from the so-called key players, who are the energy companies or the utilities, who need desperately those data, and not only raw data, they need analysis. So, to sum up, this is a very smart BI tool, business intelligence tool, not to drill down in the CRM system and obtain the best sales. This is a BI tool to drill down in utility raw data and obtain a decision. And this decision can be used from huge companies to address services. So, in terms of the business model, we are just in the middle. We are service brokers. On the right-hand side, we have the key players, huge utilities, huge distribution companies, huge energy companies, energy efficiency companies, ESCOs, energy services companies that have as an immediate service energy efficiency measures, or some to change the windows of the building to reduce the carbon footprint, CSR, corporate responsibility, green marketing. All those are services being offered by some key players. This is the right-hand side. We are in the middle, and on the left-hand side, we have our immediate customers, which means the smart metering customers. We have the customers that we are keep receiving metering information, data, in order to give the decision analysis to the right-hand side customers. So, as a business model, we are service brokers. One other smart and strong differentiation point is that we are using cloud computing. Our services are hosted in specific data centers, okay, with all the security, the ISOs that we could have. And we are actually have streamlining algorithms analyzing every 6 seconds or every 1 minute the data. One third idea that we have, and we are very much interested in offering, moving on to provisionals in the US, is that we are trying now technically to alter, to change the smart metering architecture, the existing architecture. We have specific technology, and we would like to create another type of technology in the smart grid sector, very identical to the BitTorrent network, the peer-to-peer network. We have specific technology that we could access to the end user, to the smart meter, directly without the use of any warehouses or without the use of any intermediate databases. This is another innovative approach that we have in the so-called utility sector. And we do have the algorithms to do that. So imagine that instead of entering into a BitTorrent to a torrent program to download Fringe, to download a movie, or to download MP3s, imagine that identically to the SETI at home distributed environment, we would enter into a cloud computing environment and download directly specific analysis and specific analytical KPIs from the meter themselves. So this is, we're reducing the complexity of the architecture, and we have many, many other advantages. This is a highly technical, innovative approach that we have now. One other strong differentiation point is that we are trying to use social networks. And why is that? Social networking, it's a huge capital, it's a huge invention. So we are trying to use Facebook applications, Twitter applications, and other social networks in order to create social energy communities. Imagine that if we have a community, for instance, schools, if we have a smart metering project incorporating hundreds of schools in a huge social energy network, the schools, they could actually learn from the data, learn from themselves, and the exchanging of the experience could actually move to a better awareness, could actually improve the awareness, and this means energy behavior. Awareness means energy behavior. The human factor in energy efficiency, it's great. We could, of course, have many, many smart devices that they could switch off the device that is not being used, switch off the PC, switch off the TV according to a sensor inside the home if no one is in the house. But the human factor, it's really important when we're talking about efficiency in demand response, demand side management. In order to improve this behavioral approach, we have to raise the awareness. And how do we raise the awareness nowadays? It's the use of social networking. So imagine some transparent applications that the user at his house, he could see his profile in his TV set, he could see his profile at the same time in the iPhone, he could see his profile at any digital mean at any time. This is another innovative approach that we have. So the end user is not actually obliged to enter using login and password to a specific portal and see the data. We are trying to offer anytime, any place, personalized data to the end users by using social networking.
Excellent. Excellent presentation.
Okay, this is it. If you have any questions, I'm at your disposal. Thank you very much for listening, and the presentation is at your hands, so you can freely distribute it.
Thank you so much. And are there any questions? We can take one or two questions, then we're going to have to move on. How is your company funded right now?
We are the
short answer.
In the Valley of, sorry?
Short answer.
In the Valley of Death, we are seeking seed funding. It's actually own funding. Nowadays, we are funding ourselves, the company.
Okay. Are you looking for migration into the United States?
Definitely. The smart grid market is huge.
Great. Thank you so much, and we'll speak soon.
Okay. Thank you very much, Les. Have a nice day. Thank you. Bye-bye.